Okay, let's try to use this grinder here to do a little work. As you can see, I'm only maybe 3/4 of an inch down on the outside of this. I might be 1 1/4, 1.5 inches down on this side. I'm already having problems with my guard binding into the monopole. When I turn it around, I can get a little bit more travel, but I can't see what I'm doing because of all the sparks. It's very, very time consuming. I can probably about 6 or 7 or 8 discs later get down probably about 3 inches before I finally grind out on this bolt right here. And then that'll be the end of being able to use this grinder with the zip blade. Okay, now let's try this reciprocating saw. I'm going to start on a gusset that I haven't already started cutting on and see if I can get this started here. So here we go. I already wore out the teeth on this blade. Yeah, the teeth are rounded already, so I'd have to put in a new blade now and continue on, but it doesn't cut real fast with this thick material. Okay, now let's do conventional carbon air arc process. My little cheat sheet here tells me that for a 5/16 carbon, I have all different sizes here, but for a 5/16, which is right here, the minimum setting is 350 amps. The maximum setting is 450 amps. So let's turn our machine on. This is a Miller XMT 350, and we were running it in the CC mode. It's on 304. Let's put it up to 350, which would be our minimum setting. And there's 349. Close enough. Okay. And let me put some some earplugs in here because this is quite noisy. Okay, we're going to do some conventional air arcing with conventional settings here. This is a 5/16 carbon at 350 amps, and we're just going to use this test plate here and cut some grooves in it just to show you spark patterns and what's associated with carbon air arc. So here we go. We turn on the air. Okay, you can see my cuts. The metal is removed, and it does quite an efficient job of removing the metal, but yet there is a serious amount of sparks that are thrown out from the process. And because of the heat involved, there is a little bit more heat going in because of the amperage that's involved, 350 amps. This is the low setting for this carbon. If I try to set it any lower, it'll start to stick, and it'll also put carbon into my cut, which is very, very difficult to remove. Okay, now we're going to show B&C's method of a low temperature air arcing process. We're going to change the machine a little bit here. We're going to turn the voltage down to 25. We're going to use the same 5/16 carbon again, but notice the amount of amperage that's going to be used when I do it this way. Here we go. Okay, now I don't know if you folks notice, because it's hard for us to tell with this small screen if we're getting this or not, but when I was actually cutting, my amperage was clear down as low as 90 amps. Sometimes it will spike up some when I stick the carbon a little bit, but my actual cutting amperage is between 90 and 150. Now I'm going to bump up the voltage a little bit now. I'm going to take it up to 20, let's just take it to 29 volts. That'll probably keep me from sticking the carbon as much here. Let's cut again. As low as 88 amps I was cutting at. And I don't know if you noticed, but the arc sounds a lot smoother, there's a lot less sparks, and it's a very, very cool, low heat thermal removal process.